So in this video, we're going to be looking at exercise 40 and 41 for the urinary system. So looking at the pictures, 40.1, we have a model for that. We'll come back to that. 40.2 is showing you the difference between the male and the female. When looking at this image, in the middle, you do not have to know the ureteric orifices. You do not have to know the bladder neck. Where it has the intermediate part of the urethra, cross out intermediate part and put membranous. So we're going to call it by its professional name, which is the membranous urethra. And within the male, continuing where it says spongy urethra, you can put penile urethra. I use both spongy urethra and penile urethra. I'll usually use penile urethra. So these are stuff that obviously is going to be on the urinary chapter, but both of these will also be on the reproductive chapter. At the end of this, I do have the layers of the bladder listed out, and again, we can see these when we get to the bladder model. As you can tell from this picture, we're looking at the kidney model. So this is figure 40.3. Kidney. So the outer part is the capsule, and then we have the cortex, and then we have the medulla, again, just like we saw with the lymph node on our previous practical and many other organs. It's like a peanut M&M. We have a thin candy coating, that would be the capsule, the chocolate part, that would be the cortex, and then the medulla, that would be the peanut. Structures, we have the renal pyramids. Okay. We are going to have the renal papilla. So these are like the sprinkler heads at the top or the apex of the pyramids. You have the minor calyx that join to form major calyx. So several minors will join to form the major calyx, and all the major calyces will join to form the renal pelvis, and that's what funnels the urine into the urethra. The dent, that is going to be the hilus or the hilum, and the spaces around the calyces is known as the renal sinus. Now the circulatory system part of the kidneys, because I know how much you guys have missed blood vessels, we have the renal artery. That will then branch into the segmental artery, and then that will branch into the lobar artery. Now your lab book does not show lobar arteries. If you look at the handouts for the kidney, that picture has the lobar artery labeled. So the renal branches into the segmental arteries. The segmental arteries will branch into the lobar arteries, but it's still within that renal sinus. Then we have the interlobar artery. That's going to be found in the column. The arcuate artery, it arcs at the base of the pyramids. And then we have the interlobular artery. Your book calls it cortical radiate artery and then vein. I use interlobular. So again, if you're looking at that handout from online, it does say interlobular instead of cortical radiate. So I use that one. Then we have the interlobular vein, the arcuate vein, the interlobar vein, again in the columns, and then we have the renal vein itself. So no segmental veins and no lobar veins. I don't know why, that's just how they labeled it. So this is just showing you kind of a wedge or a cross section of the kidney. So this is going to be a combination of figure 40.3 and figure 40.4. Okay, so you're going to have to kind of go back and forth a little bit. So we've got the renal capsule, the renal cortex, the renal medulla. We're going to have the interlobar artery, the arcuate artery, the interlobular artery. Then we're going to have the afferent arteriole going towards the glomerulus and the efferent arteriole leaving the glomerulus. We have the peritubular capillaries, then the interlobular vein, the arcuate vein, and the interlobar vein. Now some of the efferent arterioles will go into the vasa recta before going into the interlobular vein and the arcuate vein. This again is the renal corpuscle that is made out of the renal capsule or Bowman's capsule and the glomerulus. Okay, so we've fully moved on to figure 40.4 by now. So afferent vessel in, efferent vessel away. Glomerulus is that capillary knot. Bowman's capsule. Then we have the proximal convoluted tubule. Convoluted means crazy turns, so really kinky, curly little guy there. When we have the descending loop of Henle and the ascending loop of Henle and the distal convoluted tubule. Then we have the collecting duct, and that will end in the renal papilla, so the little sprinkler heads that are going to trickle urine into the minor calyx. Now, the next picture, we're going to take the renal corpuscle and blow it up. So this is figure 40.6. 40.5 kind of just shows you the previous structures stretched out and in detail, not a big deal. So 40.6, again, we have the renal corpuscle that's made out of the renal capsule or the Bowman's capsule, and the glomerulus, that knot, afferent arteriole coming in, efferent arteriole leaving, and coming from the Bowman's capsule, you're going to have the proximal convoluted tubule. And that's the only parts that you have to know on the renal corpuscle or the juxtaglomerular complex figure 40.6. Any of the other stuff you can just ignore. They'll be handy for lecture, but not for lab purposes. 40.7, completely ignore. Chapter or exercise 41 is urinalysis. You have a handout. Again, print that off. It has the urinalysis, so it goes through and says if you have white urine, you have this condition. If you have acidic urine, you have this condition. So even though we're obviously not doing urinalysis together as a group, you are still going to be responsible for urinalysis in word questions. So I might ask you, what does green P indicate? What do you use to measure urine? That scenario. Okay. Sorry about that. Can't stop that from happening. Stupid computer. So now we're going back to figure 40.1, which is showing you the kidney board. So ignore picture B, ignore picture C. Picture A is what this model is showing you. Now there is a major difference. Your picture shows a female because it shows a uterus, in parentheses, part of the female reproductive system in case you're having a really bad day and didn't know what a uterus was. This one is a boy. It has a prostate gland. Okay, so I would point to the prostate here instead of a uterus. But other than that, we've got the adrenal glands, those little guys that sit on top of the kidneys making hormones. Kidneys, the hilus or the hilum, that's the dent. Again, you have the renal capsule, the renal cortex, the renal medulla, renal pyramids. The minor calyx join to form major calyx, join to form the renal pelvis that will drain out through the ureter. Okay, and I'm not going to go in more detail because that was the previous pictures. So we have the ureters. Some people say ureter, some people say ureters. They're both acceptable. Then we have the bladder. Again, layers and parts. This is the trigon where the two ureters come in and the one urethra leaves. We have the mucosal layer of the bladder that's made out of transitional epithelium, and it's going to have rugae, little wrinkles so it can expand. Then we're going to have this submucosal layer. Then we're going to have the muscularis layer. That's going to have the detrusor muscle, which is a combination of smooth and, it is smooth muscle, but a combination of a circular layer and a longitudinal layer to squeeze the bladder. So your book just says detrusor muscle instead of the muscularis layer. And then we have the peritoneum up here. This is the prostatic urethra, because again, this is a male, and this is the prostate gland. The rest of the male anatomy, again, will be in the reproductive chapter. Stuff that would have been on the board. Again, you have the nephron. That is the functional unit of the urinary system. So this guy here, if this guy ain't working, you're not making pee and you kind of die, right? Because you go into renal failure. Kidneys are your primary organs. You can live without a bladder, but you cannot live without kidneys. And then layers of the bladder, again, you have the mucosa that have rugae, the wrinkles, to allow for expansion, made out of transitional epithelium. Then the submucosal layer, the muscularis layer, which your book just calls the detrusor muscle, and the peritoneum. So other than the handouts and the word questions coming from the handouts, that is it for this unit.